back, my lovely viewers. I'm always filled with joy anytime I want to shoot a video on any math Olympiad question. That's because you are amazing. Like my viewers, you're amazing. You engage, you contribute, you advise, you I'm so happy to have you. Okay. All right. Welcome to today's, let's call it a class. Okay, so today we have a math Olympiad question on the board. We are asked to find a to the power of 11 plus b to the power of 11. That's a high number, but let's do it together. First of all, let's square equation 1. We are going to square equation 1. That is because anything you are going to do here, you need AB. Okay, and to get that AB, you must square equation 1. Then we need two things to get our a to the power of 11. You know that using the law of indices, okay, if you have a to the power of, say, 6 times a to the power of 5, right? If you multiply this by this, according to the law of indices, once they have the same base, they are going to pick the base. Then you add the power 6 plus 5 to give us a to the power of 11. Okay, now that means we need a to the power of 6 and a to the power of 5 to achieve this. Okay, and we are given that a to the power of 1 plus b to the power of 1 is this, and a squared plus b squared is that. So let's just manipulate this to be able to arrive at a to the power of 6 and a to the power of 5. Then we'll multiply them together to get our a to the power of 11 and b to the power of 11. Let's get to work. All right, so like I said, we need AB. All right, and to get that AB, let's square equation 1. Let's call this equation 1 and this equation 2. We are looking for this. So let's square equation 1 squared. Okay, it's going to give us what? A plus B squared is equal to 1 squared. Now, for you to be able to solve this kind of equation, you must know your algebra identity very well. Yes, the algebra identity that states that a plus b squared is the same thing as a squared, okay, plus b squared, okay, plus 2 times ab, that is 2ab. That is an identity in algebra, is equal to 1 squared will give us what? 1. All right, remember I told you that our intention is to get AB. Nice. Now we have that a squared plus b squared is already given that this is equal to 2. So we are going to substitute that into this equation. So we have 2 plus 2ab is equal to 1. All right, now because we are looking for AB, we need AB to be on its own. So let's transfer this 2 to the other side of the equation. And if we do that, this plus 2 becomes minus 2, right? So we have 2ab is equal to 1 minus 2. So 2ab is equal to minus 1. Now we divide both sides of this equation by 2 to be able to get AB. Now this, we cancel this, we are left with AB is equal to minus 1 over 2. Now this is a very important part of this solution that we are looking for. So let's call this equation 3. Okay, all right, we have gotten the value of AB. Now we need a to the power of 3. Why do we need that? You know, I told you people that we need a to the power of 5 and a to the power of 6, right? Now to get a to the power of 5, we need a to the power of 2, which we have already, okay, dot, and we need a to the power of 3, because when we pick one base, we add the powers to get this one. Okay, and to get a to the power of 3, we need to cube equation 1 of this particular question. So let's cube equation 1 so that we can get a to the power of 3. Okay, now equation 1 raised to the power of 3 can be written as what? A plus b to the power of 3 is equal to 1 to the power of 3. Now this is another identity in algebra that states that when you have a plus b raised to the power of 3, that is same thing as a to the power of 3 plus b to the power of 3 plus 3ab times a plus b. Okay, it is an identity. You can actually do this, as in if you expand this, you will get this. All right, is equal to 1 because a to the power of 3 is still 1. All right, now let's continue. We have a to the power of 3 plus b to the power of 3 plus 3 brackets. Remember what I told you, why we had to look for ab. Okay, now look at ab here. Remember our ab is minus 1 over 2. So we are going to write minus 1 over 2 here. Okay, now brackets. A plus b is equal to 1. Yes, a plus b is equal to 1 according to our equation 1. All right, is equal to 1. Okay, so we have a to the power of 3 plus b to the power of 3. Now, plus 3 times minus 1 will give you minus 3. So it will actually affect this to become minus 3 over 2. Everything times 1 will still give you the same thing, is equal to 1. Okay, now a to the power of 3 plus b to the power of 3 is equal to 1. This minus 3 over 2, if it crosses this equation, it becomes plus 3 over 2. Okay. Now, a to the power of 3 plus b to the power of 3 is going to be equal to, now this is same thing as 1 over 1, right? The LCM of 1 and 2 is 2. Now, when 2 is divided by 1, you have 1. 1 times 1 is still 1. Plus, when 2 divides 2, you have 1. 1 times, sorry. When 2 is divided by 1, you have 2, right? 2 times 1 will give you 2. Plus, when 2 divides 2, you have 1. 1 times 3 is still 3. So that means we have a to the power of 3 plus b to the power of 3 is equal to 5 over 2. Now, this is another important equation. So let's call it equation 4. Okay? All right. Now, let's continue. With this a to the power of 3 that we have gotten, we can multiply a to the power of 3 by a to the power of 2 to get our a to the power of 5, right? Now, how do we do that? We need to multiply equation 4 by equation 2. Now, permit me to clean this. Yes, I believe you already know what we got there. Just so that I will have enough space to work with, okay? All right. So let's multiply equation 2 by equation 3. So equation 2 times equation 4, sorry, this. So we are going to have a to the power of 2 plus b to the power of 2. A to the power of 2 plus b to the power of 2 multiplied by a to the power of 3 plus b to the power of 3. A to the power of 3 plus b to the power of 3 is going to be equal to 2 times 5 over 2, right? 2 times 5 over 2. Now, 2 we divide 2, we are left with 5 here. Now, let's expand this. Okay, a to the power of 2 times a to the power of 3. Remember the identity that the law of indices or exponents that I told you, that a to the power of x times a to the power of y. Once they have the same base, you pick the base and you add the what? The powers. Okay, so we are going to apply that here. So if we say a to the power of 2 times a to the power of 3, we are going to have a to the power of 2 plus 3, which is 5, right? Now, a to the power of 2 times b to the power of 3 is a squared b cubed. All right. Plus b to the power of 2 times a to the power of 3 is still a to the power of 3b squared. Plus b to the power of 2 times b to the power of 3. They have the same base. So we pick one and we add the powers. And if we add the powers, we have 5. Is equal to 5. All right. Now, this is the main thing we are looking for. A to the power of 5 plus b to the power of 5, right? So let's bring them together. We have a to the power of 5 plus b to the power of 5 plus, now, what do they have in common? They have a squared b squared in common. Then when we open the bracket, a squared b to the power of 3 divided by a squared b squared, we'll be left with only one b, right? All right, plus a to the power of 3b to the power of 2. If it's divided by this, You are left with what? Only A. Alright, is equal to what? 5. Remember that this plus b to the power of 5, we have brought it to this side. Okay, now we have a to the power of 5 plus b to the power of 5 plus this is same thing as ab squared, okay, bracket a plus b. Alright, so we have a to the power of 5 plus b to the power of 5 plus, recall our lovely AB, right? We got it as minus 1 over 2. So it's minus 1 over 2 squared, and a plus b is 1 is equal to 5. So we have a to the power of 5 plus b to the power of 5. Now, minus 1 squared becomes plus 1, right? So it's going to be plus 1 over 2 squared is 4. Then times 1 will still give you 1 over 4, right? Is equal to 5. Now, a to the power of 5 plus b to the power of 5 is equal to 5 minus, because this plus 1 over 4, if it crosses this equation, it becomes minus 1 over 4, right? Minus 1 over 4. Okay, now let's solve. A to the power of 5 plus b to the power of 5 is equal to, this is same thing as 5 over 1. Now, let me bring this down a bit. The LCM is 4. When 1 divides 4, we still have 4. 4 times 5 is 20. Minus, when 4 divides 4, you have 1. 1 times 1 is 1. So we have that a to the power of 5 plus b to the power of 5 is equal to 19 over 4. Now let's call this equation 5. Let's call this equation 5. Okay, please permit me to wipe this side of the board. Let's go. Okay, if this is the first time you are coming across this lovely channel, please subscribe to the channel, okay? And then don't forget to on your notification bell so that you'll be notified anytime I upload a new video. Also, don't forget to like, comment, and share. Comment, especially if you have another way faster than this, easier, straight to the point than the method I used to arrive to the solution, to arrive at the solution. Okay, so we have gotten a to the power of 5 plus b to the power of 5 to be equal to what? 19 over 4. Now, our a to the power of 3 plus b to the power of 3. Sorry, I cleaned it, right? Remember that a to the power of 3 plus b to the power of 3 is equal to 5 over 2. It's very important now, okay? Now, this is what we got as our a to the power of 3 plus b to the power of 3. All right, now this a to the power of 3 plus b to the power of 3, remember what I told you, that we need a to the power of 6, so that when we multiply them together, when we multiply the a to the power of 6 with a to the power of 5, we get a to the power of 11 that we are looking for. And the only way to get it from this a to the power of 3 plus b to the power of 3, in case you can't see it from there, a to the power of 3 plus b to the power of 3 is equal to 5 over 2. Okay, the only way to get a to the power of 6 from here is if we square this. Yes, because a to the power of 3 squared will give us a to the power of 3 times 2, which is 6, according to the law of what? Indices. So let's square both sides of this equation. So if we do that, we have a to the power of 3 plus b to the power of 3 squared is equal to 5 over 2 squared. All right, now we have, when you have a to the power of 3 squared plus b to the power of 3 squared, using the law of using our algebra identity, this can be written as a to the power of 3 squared is what? A to the power of 6, just like I explained, plus b to the power of 3 squared is b to the power of 6, plus 2 times this and this, right? 2 a to the power of 3 b to the power of 3, okay, is equal to 5 squared will give us 25, divided by 2 squared will give us 4. Okay, let's continue. So we have a to the power of 6 plus b to the power of 6 plus 2 brackets, this same thing as ab to the power of 3, right? is equal to 25/4. Okay, so we have a to the power of 6 plus b to the power of 6 plus 2 brackets ab is minus 1/2 raised to the power of 3 is equal to 25/4. Okay, don't get tired, we are almost close to the solution. So we have a to the power of 6 plus b to the power of 6, all right, plus now minus these two brackets. Let's just 2 brackets minus 1 to the power of 3 will give you minus 1 over 2 to the power of 3 will give you 8, right, is equal to 25/4. All right, now let's continue. So we have a to the power of 6 plus b to the power of 6 plus, now these two we divide 8, we have 4. So what we have here now is minus 1/4 is equal to 25/4. All right, so we need a to the power of 6 and b to the power of 6, right, is equal to 25/4. All right, this plus, let's transfer this minus 1/4 to the other side. It will become plus 1/4, right, plus 1/4. So we have a to the power of 6 plus b to the power of 6 is going to be equal to, since they have the same denominator, is over 4, right. Now 25 plus 6 is 26. Now let's reduce this to its lowest term. If 2 divides 4, we have 2. If you divide this, we have 13. So this is same thing as 13/2. All right, this is another important equation. Let's call it equation 6. But there is no place to write it here. So this is another equation, equation 6. Now recall what I told you. For us to now get a to the power of 11 plus b to the power of 11, we need to multiply a to the power of 6 and plus b to the power of 6 by a to the power of 5 plus b to the power of 5, right? So this is equation 6. So equation 5 times equation 6. So we are going to have a to the power of 6 plus b to the power of 6 multiplied by a to the power of 5 plus b to the power of 5, this is a, is equal to 13/2 times 19/4, right? 13/2 times 19/4. Okay, now a to the power of 6 times a to the power of 5 will give us a to the power of 11, okay, now plus a to the power of 6 times b to the power of 5 is a to the power of 6 b to the power of 5. Okay, now let's go to b to the power of 6 times a to the power of 5 is still a to the power of 5 b to the power of 6 plus b to the power of 6 times b to the power of 5 is b to the power of 11 is equal to, all right, now 13 times 19. 19 times 13, 3 times 9 is 27, 3 times 1 is 3 plus this is 5, 1 times 9 is 9, 1 times this is what, 247. So we have 247 over 2 times 4 is what, 8. All right, now a to the power of 11 plus b to the power of 11 plus, now what do they have in common? They have a to the power of 5 b to the power of 5, right? A to the power of 5 b to the power of 5, okay, bracket. Now this is what they have in common, sorry, so I'm going to open the bracket here. Now when this is divided by this, you are left with only one a, right? So we have one a plus when this is divided by this, you are left with only one b, okay, is equal to 247 over what, 8. All right, now a to the power of 11 plus b to the power of 11 plus, now this same thing as ab to the power of 5, right, times a plus b is 1. Yes, Recall from our equation is given that a plus b is equal to 1, is equal to 247 over 8. Alright, let's bring this up here. So we have a to the power of 11 plus b to the power of 11 plus our ab is minus 1 over 2, right? Minus 1 over 2 raised to the power of 5 times 1 will still give us the same thing, is equal to 247 over 8. Alright, a to the power of 11 plus b to the power of 11 plus now minus 1 to the power of 5 is still minus 1. Now 2 to the power of 5 is 32, is equal to 247 over what? Over 8. Okay, so a to the power of 11 plus b to the power of 11 is equal to 247 over 8. Now this minus 1 over 32, if it crosses to this side, it becomes plus 1 over 32, right? So we have plus 1 over 32. Alright, so we have a to the power of 11 plus b to the power of 11 is equal to, now the LCM of this and this is 32. When 32 is divided by 8, you have 4. 4 times 2, 4, 7. 247 times 4. 4 times 7 is 28. 4 times 4 is 16. Plus 2 is 18. 4 times 2 is 8 plus 1 is 9. So we have 988. So we have 988 plus, when 32 is divided by 32, we have just 1. 1 times 1 is what? 1. Alright, now we have a to the power of 11 plus b to the power of 11 is equal to 989 over 32. And this is our final solution. Thank you so much for watching. Have a lovely day. Bye.